Hi everyone, I hope you guys having a good time right now. We are group 3 and from class KCS 1102B. So today, the topic we're going to talk about is application of differentiation. Before that, I'm going to introduce you to my group members who has worked really hard for these presentations. The first one is ATHIRAH binti NAZRI and her metric number is 2021479718. And the second one is Anisya binti Muhammad HAPIZ and her metric number is 2021833434. And the third one is NURSHAZA binti KAMARUDDIN and her metric number is 2021212892. And the last one is me, NAFISA binti Muhammad SHARBANI, 20212127 and 42. So, this is the contents that will be presented to all of you. There are introduction, problem statement, problem solution, conclusion, and references. Okay, the first one we're going to start with introductions. I will let you know about the definition application of differentiation. The derivative is defined as the rate of change of one quantity with respect to another. In terms of functions, the rate of change of function is defined as dy dx equal fx equal y prime. The concept of derivative has been used in small scales and large scales. Next, I also got some examples of application to make you more interested in this topic. There are related rates, analysis functions 1 and 2, applied maximum and minimum problems, and Rolle's theorem.
Applications of differentiation. Related rates are rates of change of two or more quantities that are changing over time. If we know how the variables are related and how fast one of them changes, we can calculate how fast the other one changes. Typically, this usually involves writing an equation relating the two variables and taking the equation's derivative with respect to time. Problem statement 1. A ladder 10 meters long leans against a wall in a building. When the lower end of the ladder is pulled away from the wall, the top of the ladder will fall down to the floor. If the top of the ladder will fall down at a rate of 4 meters per second, what is the rate of the lower end of the ladder moving away from the wall when the lower end of the ladder 8 meters from the wall? Problem solution. First step, we need to highlight the keyword. The first keyword is ladder 10 meters long leans against a wall. The second keyword is the top of the ladder will fall down at a rate of 4 meters per second. The third keyword is rate of the lower end of the ladder. And the fourth keyword is the lower end of the ladder 8 meters from the wall. Second step is to draw a diagram. Imagine that the 10 meters is a ladder landing on a wall and the bottom of the ladder is 6 meters long. However, when we push it towards the wall at a rate of 4 meters per second, the value of the bottom decreased. So now, we want to find the rate of the lower end of the ladder moving away from the wall when the lower end of the ladder 8 meters from the wall.
The third step is we have to do the calculation with the information that we get from the equation and the diagram earlier. In the solution, W is wall and F is for the floor. This question asks to find the rate of the lower end of the ladder, which dF over dt. In order to solve this, we can use theorem Pythagoras equation, where W squared plus F squared equals to 10 squared. Then, the equation that we will get is 100 minus W power of 1 over 2. We have to differentiate it using chain rules and we will get negative W over square root 100 minus W squared. Next, we have all the values that we need in the equation dF over dt equals dF over dW multiplied by dW over dt. Substitute the dF over dW with negative W over square root 100 minus W squared and substitute the dW over dt with 4. The last step is when W equals with 8, substitute the W with 8 in the equation negative 4W over square root 100 minus W squared. The final answer will be negative 16 over 3 meters per second. And that's it for the problem solution 1. Next, We move on to another application of differentiation, which is applied maximum and minimum problems. Applied maximum and minimum problems is the process of determining maximum and minimum values is known as optimization. For example, we are trying to reduce costs or find the least amount of material required to make a specific object. The function, together with its domain, will suggest which technique is appropriate to use in determining a maximum or minimum value. Problem statement 2. A designer of box making company wants to produce an open box from a piece of card with the width of 16 cm and length of 20 cm. The box is made by cutting out squares of length X at each corner. The sides of the paper are folded up to form the box as shown in figure 1. Show that the volume of the box is V equals to Fx cubes minus 72x squares plus 320x. B. Find the value of x so that the volume of the box is maximum. C. Find the dimensions of the book so that the volume of the box is maximum.
Problem solution 2. First step is we need to insert important keyword on diagram. We can label X at each of the corners where the sides of the paper are folded up to form the box, and it's actually the height of the box. Second step, do the calculation. For question A, we need to confirm if the volume of the box is equal to 4x cubed minus 72x squared plus 320x or not. First, we will find the equation of length L and width W, and then using formula for volume, which is length multiplied by width multiplied by height, it will be 20 minus 2x multiplied by 16 minus 2x multiplied by x. When we solve this volume equation, we can see that the final answer is same with the given answer, 4x cubed minus 72x squared plus 320x. Moving on to question B. We are required to find the value of x so that we can find the maximum volume of the box. Step 1. We need to find the derivative. Volume is equal to 4x cubed minus 72x squared plus 320x. After we differentiate, dv over dx will be 12x squared minus 144x plus 320. Step 2. Let the derivative equal to 0. So, 12x squared minus 144x plus 320 equal to 0. Now, we can see that it became a quadratic equation where a is 12, b is negative 144 and c is 320. To find value of x, we will use quadratic formula. X equal to negative b plus minus square root of b squared minus 4ac and over 2a. After we apply the formula to the equation, the values of x is 9.055 and 2.945. Third step, solve the question. In the last step, we need to do second derivative test, which is finding d square v over dx squared. To find it, the value of first derivative will be differentiated again, and we get 24x minus 144. Lastly, the equation will be tested using values of x. The first value got 73.32 as the volume, meanwhile the second value of x get negative 73.32 as the volume. We can conclude that the maximum value is x equal to 2.945 because it was a positive answer. For the last question, which is question C, we need to find the dimensions of the book so that the volume of the box is maximum. Since we already got the maximum value of x, we will apply it to the original equation of volume, which makes x will be replaced with 2.945. The answer will be 420.011. In conclusion, we can solve this problem by using methods such as chain rule and implicit rule. Next, we must understand the question properly in order to solve it. Lastly, in everyday life, derivatives are constantly used to help measure how much something is changing. Knowing how to use derivative When to use them and how to apply them in everyday life can be important parts of any profession. So, learning as early as possible is always beneficial. This is all the references that help us with the assignment. That's all from us. Special thanks to Madam Baizura and all people who participate on making this video.
Thank you.